Welcome to Lesson 1 of the Mastering Geodatabases course, looking at geodatabase fundamentals. This lesson will give students a solid understanding of geodatabase fundamentals, like creating a geodatabase and its components. We will also look at available configurations to assist with customizing the geodatabase to help manage performance and functionality. As well as the summary information we'll go through here. This lesson will also include 2 demonstrations of creating a geodatabase and its components and options for importing and exporting data. This lesson is intended to provide students at the beginner level with summary understanding of geodatabases. Students with more experience could move on to Lesson 2 if they want to, where there is more advanced aspects of the geodatabase start to be discussed. The geodatabase is the main data type used for data storage in the ArcGIS environment. When data is published to ArcGIS Enterprise, the geodatabase configurations will flow through into the published services. This ensures the geodatabase configurations provide the functionality to help with data management when using web and mobile applications. The 3 types of geodatabases that are available are personal, file, and enterprise geodatabases. The most common of these is the file geodatabase. It can be created from desktop applications on any PC and has a wide range of functionality. This geodatabase type is the main focus of this course. It is used to store spatial datasets called feature classes and non-spatial data in the form of tables. Other key advantages of the geodatabase data type is the additional rule-based configurations that are available to assist with data management, and the ability to code in relationships between feature classes and tables. To implement relationships, all feature classes and tables must be stored within the same geodatabase. Relationships can't be created between geodatabases. Geodatabases also have the ability to create data types for advanced spatial modeling, called extension datasets. These will be covered in Lesson 4. Finally, geodatabases provide storage for custom toolboxes as well. The image on the right-hand side shows the ArcCatalog menu for creating geodatabase components. The file geodatabase allows for multi-user access and editing, as long as simultaneous editing occurs on different feature classes or tables. Multi-user editing is not possible on the same feature class or table. To finish up this brief summary, it's good practice to have an understanding of file size limits within file geodatabases. The size limit per feature class is 1 terabyte with standard configurations. This can be modified to either 4 gigabytes or 256 terabytes with the use of configuration keywords. This slide outlines the feature class configurations available within a file geodatabase. Some configurations are set when a feature class is created, others can be modified once a feature class has been created, and some configurations can be modified either during or after setup. This list of configurations provides geodatabases with the ability to greatly enhance data management. The configurations that need to be set during feature class creation include specifying the geometry type, the XY tolerance, and any configuration keywords. Fields, aliases, domains, the coordinate system, and geometry properties can be set either during feature class creation or afterwards. Then the following configurations can be set up only after the feature class has been created. This includes enabling editor tracking, setting the feature extent, enabling attachments, manually refining indexes, and applying subtypes. The 3 minimum configurations required for a feature class are highlighted in grey. The key takeaway from this slide is to make sure that the configurations that can only be set up during feature class creation are configured correctly during the creation process. If these are wrong, a new feature class will need to be created. This could be a difficult process depending on the complexity of your geodatabase design. Configuration keywords give the ability to modify feature class behavior. The configuration keyword is set when a feature class is created. The file geodatabase configuration keywords are shown in these tables. Default settings are applied using the default keyword, which is set automatically. This keyword will cover most of the uses for a feature class, but it's good to know about the other available keywords and what they mean. The other keywords in the first table relate to feature class size. The size can either be increased or decreased to suit system requirements. There is also an option for more efficient storage of non-English text characters. Table 2 relates to whether data is stored inline or out of line. When using a feature class, inline storage means all data needs to be loaded into memory prior to any querying or editing. For out-of-line storage, not all data needs to be loaded prior to editing or querying. Out-of-line storage can be an option to look at if you're working with very large feature classes. Please keep in mind that enterprise geodatabases have additional keywords and can also have custom keywords set up as required. Now we're going to run through a software demonstration of creating a file geodatabase and its components. In one of the previous lesson slides, I gave a summary of the various configurations for feature classes that are stored within a geodatabase. This demonstration will focus on these configurations and how they can be set up during as well as after feature class creation. To start this demonstration, we're going to create a new file geodatabase. This can be done through the Catalog pane in ArcGIS Pro. The Catalog pane can be found under the View tab and clicking the Catalog pane button. We're going to create our new file geodatabase in the Databases folder of this open project. This can be done by right-clicking Databases and selecting New File Geodatabase. Now we need to specify the location and name of our new geodatabase. I'm going to call this one Sample GDB Lesson 1 and click Save. You'll see under our Databases folder we now have a new database that is now empty and ready for content. We're going to start adding content to our geodatabase by creating a new feature class. This can be done by right-clicking on the geodatabase and selecting New and selecting Feature Class. Firstly, we need to enter the feature class name. In this example here, we'll call our sample feature class Conservation Polygons, and we'll include a reference to the coordinate system. It's also good practice to provide an alias name. This is the name that will display when a user opens the feature class and can help provide a more user-friendly experience. For this example, we'll call our alias Conservation Areas. Then we need to specify the geometry type and properties that we want enabled for the feature class. As the name suggests here, we're wanting to set up a polygon feature class, so we'll keep our geometry type set to polygon. The next step is to add in the required attribute fields. This is done by adding in the field name and data type. For this example, I'll create two fields. The first will be called Site ID, and it will have an integer data type. The second field relates to the conservation status of each polygon. So we'll give this the name Conserve Status, and we'll keep this as a text field. For all fields, additional properties can be set at the bottom of the Create Feature Class window. For the site ID, we're going to provide an alias name. Also, as this is an ID field, we will set the Allow Null Values property to No to ensure that all sites are given an ID value. This can be set from the drop-down list. For the conservation status field, we will also add in an alias. For this field, we will allow null values in case the conservation status isn't immediately known for each polygon. But we will also specify a default value that can be applied in case the value isn't provided. And for this example, we will set that to be unknown. And we also need to define the text field length. The text length can't be modified once a feature class has been created, so make sure you give the text field enough characters for any possible values. For this example here, we'll set that to be 100 characters. This tool also provides the ability to import field schemas from other feature classes or tables using the Import button. This button can be found at the top of the window. Navigate to the required feature class or table to have its field schemas imported into the new feature class. Now we need to specify the coordinate system. This can be set by navigating through the drop-down lists or using the search tool. We will set the coordinates system to be GDA 2020 Zone 56, which is a common coordinate system used on the east coast of Australia. For this, I'll start off with a search and then navigate through the drop-down lists to find the coordinate system that I need. To help with finding coordinate system files in the future, a coordinate system can be saved to the Favorites menu. This can be done by right-clicking and selecting Add to Favorites. There are also tools here to create new custom coordinate systems or to import a coordinate system from another feature class. This can be found in the menu at the top of the window. Now that we've set our coordinate system, the next step is to set the X, Y, and Z tolerances. The tolerance relates to the minimum distance between geometry points before they are deemed to be in the same location. It controls how detailed and accurate geometry objects can be. As the GDA 2020 Zone 56 coordinate system has a unit of meters for the X, Y, and Z axis, we will leave the tolerance to 3 decimal points. This allows features to be represented that are 1 mm apart. If the default tolerance is unsuitable, it can easily be changed by simply typing in the text field. The next window relates to the resolution. This is the underlying grid that all coordinate values are snapped to when drawn in the map window. As a rule, the resolution should always have a higher level of detail than the minimum tolerance specified in the previous step. In most cases, these values will just be left as is. Finally, we need to specify the configuration keyword for the feature class to help customize the feature class functionality. This can be set from the drop-down list or kept as default. The drop-down list can be activated by selecting this option and then picking the keyword from the list. In most cases, this will be left as default. Finally, we click Finish to create the feature class. This new feature class can now be seen in the Geodatabase and is ready to bring into ArcPro to start populating with data. As mentioned earlier in this lesson, there are various feature class configurations that can only be set after a feature class has been created. We will now take a brief look at some of these configurations. The list of available post-creation configurations that we will look at here includes editor tracking and attribute indexes. There are some additional configurations mentioned in the lesson slides that haven't been covered in this demonstration. These will be covered in subsequent lessons of the course. Editor tracking is where data is captured on which users created and last edited each feature. This doesn't provide a full history of edits to all features, as data is only captured for the latest edits, but it's still a useful resource for Geodatabase administrators to track who is adding and editing data. Editor tracking is also a requirement for some published service configurations like branch versioning. Attribute indexes improve performance when running attribute queries on a feature class. When you perform an attribute search without an index, ArcPro will look at every row in the table to find the required values. This can be very time intensive for large feature classes. An index provides an alternative method of finding required values that doesn't involve searching every record in the attribute table. Editor tracking can be configured in the feature class properties. The steps for setting up editor tracking include selecting editor tracking in the list and enabling it in the top of the window. Editor tracking stores data for the users as well as the date that edits were made. If fields have already been created to store editor tracking data, These can be selected from the drop-down lists. Alternatively, ArcPro can automatically create the required fields with the field names shown in these drop-down lists. If you're going to